Hi, team, and welcome to the what is now a little bit of a long-awaited SSPI data APIs tutorial. So we're going to talk about, how APIs work, the sort of theory and infrastructure behind them, why they exist, and then how we're going to actually implement them for the SSPI. I'm going to run through some of these slides. They'll be available online, and there's a lot more detail here, and there are links to some other readings if you're like actually really interested in this, because, it goes deep here. But for the tutorial, at least, I'm going to kind of run through these and give you sort of the bare bones understanding that you need to be working with the APIs. So, what is the internet anyway? So this is sort of the theory. The internet basics. The internet is a connected network of computers, and that's really all it is. Like, they're just a bunch of computers, and they're all talking to each other. Now, what exactly that means and how you get them to all talk to each other in a sort of sensible way, that's all the complexity. But for the most part, all you need to know is that each computer on the network can sort of dial up another computer and ask for information. So you can say, hey, my, MacBook here could talk to, say, my professor's MacBook and say, oh, yeah, I want this. And it sends a request and their computer sends it back. And the computer making the request is called the client computer, and the computer fulfilling it is called the server. And you might have, you definitely have encountered URLs before. That means Uniform Reference Locator, and that's telling you when you go into your web browser and you type like www.instagram.com, then that's telling you go look at the computer that Instagram is using to serve the web page. And, you know, for URLs, this is a way of getting what's called an IP address. So there's the service. So just to before we get into it, there are a lot of words here, and it's really difficult to keep them all straight. And so URL uses DNS to look up the IP address, and very quickly it's alphabet soup, right? So don't worry too much about the words right now. I mean, you're gonna learn them if you ever are going to go into things that are like more technical, but for the most part, I'm sure you know what a URL is. It's just the address of a page, and that goes to some kind of dictionary that, these dictionaries are stored. This is what DNS is. It's like a dictionary that says, okay, what IP address, what computer does that correspond to on the network? And then it routes you there. Now, that's a lot of sort of messy stuff, but it'll become clearer as we do more of this. So optional reading here is how does the internet work? It's really old. It's from like the 2000s, like early 2000s, but the internet basically still works in that way today. And it's really clear, and it's got lots of nice pictures if you're actually interested in how, this information gets sent across the network, but it's not going to be important for us here. All right, internet basics. So yeah, we have a computer, we have another computer, one sends a request, the other sends a response, and that is the internet. On sort of like, this is the most basic picture you can draw of what the internet is. Now, of course, it's more complicated than that, and maybe, for now, change this. So maybe you're not talking to your friend's computer or your professor's computer or whatever example I was using earlier. You're talking to what we would call a server. And a server, in general, is just any computer fulfilling the request. But oftentimes that word gets used to mean a big computer that isn't really for, browsing the internet or, human use. It is for serving responses back to clients. And a lot of times there are lots of servers out there. So maybe Instagram, to continue using that example, that's going to be sort of our pet example for this tutorial, has a whole rack of servers that they bought and keep maintained somewhere where computing is cheap. So cheap electricity, and it's not too hot outside, to keep the servers cool. And so they have this rack of servers, and maybe one client is requesting, and then another client is requesting from a different server, depending on location. And these servers can also talk to each other. And, of course, it's even more complicated than this. And then once you start getting into, okay, maybe Instagram actually pays for computing on the cloud, which is really just a set of really, really fast servers that you can pay for as a company, so you don't have to maintain your own. And, you have this complicated mess of connections. And this picture is basically as complicated as we need to get for what the internet looks like for our purposes. So there are lots of servers out there and lots of places to dial up. And when I was talking about URLs before, your computer on the browser, let's say you're here, types, you type instagram.com, and then it goes and looks, and here maybe is a DNS server. And so that's going to have the dictionary stored on it, and it's going to look up where to send your URL request, right? And so it sends that out to here. Maybe this is the Instagram cloud that Instagram is paying for, or, maybe it's at Facebook, or maybe Facebook is paying Amazon Web Services to host their stuff. And so then it sends you back the information you want, which is like, the front page of Instagram, which is a big HTML, CSS, JavaScript file. And it sends that back to you through this route here. So it'll go boop, boop. And that's how like maybe you get the actual response fulfilled. Okay. Yeah, so the URL gets resolved through DNS to an IP address, and each computer on the network has a unique IP address. And if you've heard of IP addresses before, it's usually when you're like trying to resolve your Wi-Fi difficulties or something like that. That's what that is. It's a uniform, unique identifier for any computer on the whole internet. So every computer that is connected to the internet has a unique IP address. So that is maybe one thing to take away. And URLs map uniquely to IP addresses through DNS services. That's a lot of words. All right, moving on. So we're going to now use this like on our machine. So what I'm going to do is I'm going to visualize this function called ping here. So, on your terminal, which I'll show you how to open in a second, or your command prompt if you're using Windows, you're going to send ping to Instagram.com, and you're going to request a packet and return an Instagram.com, which gets resolved to some string of 4, 3-digit numbers. Will send you back the information you want, which is the front page of Instagram. And ping is actually going to log the time it takes for a request and receive cycle to execute. And this time matters because, if you've ever had really bad connection to something, this time can be really long and it takes forever to load. And that's really bad for the user experience. And so Instagram wants this time to be really short, and you as the user want this time to be really short so that, you can get a lot of information really quickly and it doesn't take 10 minutes to load a single photo. But early internet, that would definitely do that. So let's pop out of this tutorial for a second, and I'm going to open terminal. So I'll pause so you can see it on the tutorial, and I'll make it full screen. Okay, so this looks really scary, but I'll clear this for now. And so you can type commands into the terminal to get it to do things. So you'll see a couple common ones are like cd is change directory, ls tells you what's in the current directory. So I'm currently in my root folder of my directory, and if I wanted to go to, say, my documents folder, I could go cd documents, and then I could list ls what is in my documents folder. Now, that's not particularly important for what we're doing, but just to get a sort of feel of what you can do here, I could touch a file, which means to create a file, or I could mkdir, which is to make a directory, or I could, do anything like that. But we're going to be using ping. And ping is a kind of funny little command that will take a URL and it will ping it. And, you might have heard ping in the context of online multiplayer video games, in which case they're talking about this time here, 44 milliseconds, which is actually quite slow. So when I was doing an earlier version of this tutorial and sort of trying to figure out what I wanted to talk about, I was actually getting like 7 or 8 milliseconds. So 44 is not fast. Now, you should do this on your machine too. So open up your terminal, open up your command prompt, run ping of whatever website you want. And what we'll see, so I'm going to Control D, or I mean Control C to get out of this. Yeah, use Control C. It's called a keyboard interrupt, and that will stop it from doing anything. And yeah, so ping is going to take this, and the first thing it's going to do is try and resolve where it's going, because we have to figure out where we want to get the packets from. And so this is what this line is doing. It's saying ping zp42 instagram.com, c10r instagram.com. And so what is this doing? I'm not exactly sure exactly what this means, but this is basically taking this and picking which server it's going to go to. So it's pinging this server. And then, Instagram has multiple servers because it's a really big service. And the IP address, which we've used earlier, is this set of numbers here. So IP addresses always look like some number, period, some number, period, some number. And, these are anywhere between 0 and 255, I believe, these numbers in between the dots, and they don't print the zeros, like leading zeros here. So this IP address is unique. This is the one place I can get this stuff. And if I wanted to, I could say ping of this IP address, and it starts pinging that one directly. And all this first step is doing is taking yeah, Instagram.com, and it's resolving it into this particular IP address. And then, it says, okay, we're gonna send 56 data bytes. A byte is 8 ones and zeros in a little block. And, you know, yeah, you think in gigabytes or gigabits, or you have a 256 gigabyte device or something like that. Well, that's what this is. So it's sending a little stream of 56 packets, or 56 little chunks of 8 ones and zeros. And here it's 64 bytes, and it's just sending those little packets across so that you can see how fast it or how long it takes to receive a packet. Perfect. Okay. So that's ping, and congratulations, you've pinged an address. All right, moving on in the tutorial to curl. So curl is sort of the bread and butter of what we're going to do. So curl is actually not called curl, it's CURL, and that means client URL. So you are the client of this URL, basically. And what it's going to do is you're going to say curl -x, and the -x is a sort of option to take an argument here. And there are different things you could tell it to do. You could tell it to get, you could tell it to put or post or delete information from the server. But for our purposes, since we're getting data, we don't need to mess with any of the other methods. We are going to get https://www.instagram.com. Now, one little wrinkle here that you'll notice is here we go to www.instagram.com, and here we use https://www.instagram.com. Now, why do we do that? Is that just like style? Well, let's try it out. So I'm going to ping https://www.instagram.com, and you'll see it doesn't know what that is. And in particular, DNS cannot resolve this because HTTPS actually means something. This isn't just like random junk you stick on here. Like, it has a reason for existing. And HTTPS is the secure version of HTTP. So old, did I say TTT? HTTP. And old websites have HTTP addresses. And let's see if we can find one. Let me see. Maybe if I go to my work in progress personal website, I don't think I've configured this. Oh no, it's HTTPS. Well, who knows? But there are sites out there that are HTTP, and a lot of times your browser now will actually warn you from visiting them because they're not secure. So HTTP means Hypertext Transfer Protocol. Right. And again, I said, it's going to be alphabet soup. Here's the alphabet soup. So HTTP is telling you what get is, what post is, and what delete is. And it's just a text file that takes some extra stuff. And we're not going to really need to know how to use it super deeply because we're only going to be using get, and get is kind of the simplest one. But in general, HTTP is, a really good way of standardizing communication over the internet. So basically all sites you visit, if you look at this, they're HTTPS. And the reason we can't use it in ping is because this is actually telling you how to make an API call. And what ping wants is not, an API call or an address for the API stuff to go to. What it wants is just this www.instagram.com, which is telling you what. So it's telling you what computer to send it to. So this is saying, make an HTTPS request to this computer. And ping only wants to know this computer. It doesn't want to know what transfer protocol it's using because it's not actually doing any transferring. We're just transferring these little, fake strings of 64 bytes that are telling us round trip times. And so when we use curl, because we're making a request, we have to use HTTPS. And if I go curl x get, this might work because it might assume, but I think this should make an error. Let's see. Yeah, it doesn't get anything because there's nothing here to transfer. Yeah, so it hasn't errored, but if you see we put in this -x, HTTPS, it's telling you, okay, now I know how to get because I know we're using HTTPS, and it didn't know that before, so it didn't know how to get anything. But now when we add this in, it's saying go to this computer, so it'll resolve that into an IP address, and then it'll get from it. So what do we get? Well, we get a whole bunch of stuff. And what this is is Instagram. So when I say that, what I mean is this is the front page of Instagram, which is just a big HTML document with these are JSON files. These are going to be really important to us later. And this is CSS, which is used to style HTML files. And, here is the beginning of the HTML file. So it's telling you what type of HTML it is, and it's got all of the information you'd ever want from it. And this is a lot of stuff. And this is what the people who work at Instagram get paid to write, or they write the things that create this. So this is why they need a billion developers at Instagram to make it all run, because it's really complicated and somebody has to figure out how all of this fits together to make Instagram into the user experience that it is. But for us, we are just grabbing all of that information right here. And so if we wanted to look through this to find certain things, we could extract information. And that's what we're going to do when we do the API data stuff with extraction. But yeah, just to briefly summarize, CURL takes a -x, and this you can think of sort of as one command. And then we have to tell it to either get or post or del, which is delete. And we're only going to use get because we don't want to be messing with anybody's database. And usually the databases are secure. And then we have to use HTTPS here to tell Instagram how we want to communicate. It doesn't understand get unless we use HTTPS. And the HTTP methods is another word for functions, or things you can do, right? So HTTP tells you certain things you can do, like get, post, and delete. Let's see. Yeah. Okay. I think that sort of gets a first look at what we're doing. This is a full API request, so we've sent a get request to the Instagram API, and we could do that also by going back to our IP address that we saw for Instagram, and we could send the get request directly to this IP address, let's say. Let's see if that works for us. They might give us an error because maybe they want to route us through a different IP address, but let's just see. -x, and then what we're going to do is we're going to say get, and then we're going to go, well, we need to tell it to use https://, but then we're just going to post this here, and let's see if they get it. Curl failed to verify the legitimacy of the server and therefore could not establish a secure connection to it. So Instagram, when they route us to the particular server they want us to use, we can't just request willy-nilly from any server. They want to send us to a particular one. And so it does not like that we try to use a particular IP address of an Instagram server to get the general Instagram.com front page. And so we could use this to go, we can use this method to, query more specific things. So we've been querying the front page of Instagram, which is probably serving me some kind of message that I need to log in, because that's how Instagram works now. But we could query a more specific page, let's see, https://. We're always going to need that to tell us what kind of way we're going to do it. And then let's go to Instagram.com/Billie Eilish. Just got concert tickets and I'm excited. So that didn't work. And why didn't it work? I think we probably need a slash out here, and that is just telling us yep, there we go. Okay, so now we've been served Billie Eilish's Instagram page, and yeah, you can see title Billie Eilish, and then it's telling what user, Instagram photos and videos. Let's see. These look like these long strings here are probably encodings of photos. That's usually how photos are encoded online. Yeah, so this is her Instagram page. Perfect. And if we copied all that into our browser, we would be able to see what it is, and your browser knows how to render all of this together. Okay, so that's curl, and curl is basically what we're going to be using to get stuff. It's just we're not going to be using it as curl. We're going to be using it in R. Okay, part 2. Web API basics. So I'm going to kind of run through this section. I wrote a lot here and there's information on the slides, but the basic idea is what is this? API stands for Application Programming Interface, which is entirely unhelpful as a description, but web APIs are how everything on the internet works. And for the SSPI, it's going to be a way for us to pull in large amounts of data easily, and it's a standard source that we can go to and doesn't change very much. But what is an API? So this is a set of subroutines, definitions, and protocols that are tools for building software applications. And we actually kind of have seen this before, or this kind of definition before, with HTTP. And so HTTP is a set of standard protocols. Get, post, and delete are the standard protocols. And every website that has a server is going to have an implementation of get, post, and delete that helps you get, post, or delete exactly what you want. And there are a couple other ones like patch and put. There are a bunch of them, but the ones you're going to mainly use are get for us. And if you do any sort of web development, you use the other ones too. But yeah, take CS61B for more details on what an API is in general. So you're going to implement APIs in 61B. That's kind of like the whole focus of the course. And we're going to focus on web APIs, and I'll probably just say API, even though I mean a web API. And for web APIs, the absolute standard thing is HTTP, which is used for almost everything on the internet. Okay, yeah, so web APIs enable computers, applications, and services to send and receive information by providing well-documented, that's important, and uniform, that's also important, language for transfer of information rendering your services. And so everybody in software engineering, everybody who uses these things knows what get means, knows what put means, knows what delete means, and knows what post means. And everybody can then use the same language, and all these services together can use the same language. And what do I mean by that? Imagine you're trying to design Instagram, and pictures are big files take up a lot of space. And so you need a way to send and receive pictures over the internet from Instagram's sort of back end, is what it would be called, where they store all of the photos to your computer. And so you can think of APIs as this sort of set of plugs, and the plugs have labels next to them. And each time your application on the front end plugs into the Instagram backend, it knows exactly what to send you. And so you can say, okay, go to this particular plug and send a GET request to get Billie Eilish's information. And then you can go to Taylor Swift over here, and you can go to Ed Sheeran over here, or whatever, right? And, everybody has different ones, and certain people have different levels of access, right? Like, if Billie Eilish is posting to her Instagram, she can actually use the post methods inside of her plug, whereas no other user who is, going into that area can do that. And the plug metaphor is useful because we don't actually care what happens behind the plugs as the users. And that's the job of the backend engineers to implement. And so we sort of hide away all the complexity that happens on the backend. And the users just have a couple options. They can get, they can put, they can post, or they can delete, stuff like that. And these are not particular to Instagram at all. These are totally general, and everybody's using these 4 couple commands. 5 or whatever it is. Okay. And this is sort of the idea of abstraction barriers in computer programming. And you don't need to know how something is built. You just need to know how to interact with it. And you provide a standard set of interactions that everyone then knows. And on the back end, you can sort of change how that works to make it more efficient, or make it better, or change the structure, or make it more secure, whatever you're trying to do. And the idea is that's never going to change how the user interacts with it. They're still going to know how to get, post, put, and delete, and whatever. And you don't really need to know how those things happen. You just need to know how to use the couple commands you need to know. And so this is a general concept in all of computing. And you don't need to know how, Finder on Mac or Files on Windows sort of implements how things are stored in file structures. All you need to know is how to navigate around your files and how to create a directory and delete a directory. And all of your computer's operating system is taking care of the back end of that. And you don't need to know, okay, now I go to this address in memory and I change these ones and zeros to this other set of ones and zeros. You don't need to worry about that. And that is sort of hiding all the complexity of how files actually get stored inside an abstraction barrier, which is then, making it easy for you, the user, to use. And same way, you don't need to know how your computer processes input from the keyboard. You just need to know how to type. And yeah, so the hardware that handles this is actually quite complicated because there are a bunch of different inputs, and, you have to send it all through processing gates, and, you don't want your user to have to think about that. You just want them to be able to type. Exactly. So web APIs are making it so that you don't need to know everything about how a server's data structure works to get what you want from it. You can just get from it, or you can just put to it, or you can just patch to it, or you can just delete from it. And the back end, which might be a super complicated, messy thing that really smart people get paid a lot of money to maintain, you don't have to know how that works. Perfect. And why would you do this? Well, one thing is security. And so you want to be able to have secure APIs. And what that means is you can manage who knows what. Like I was saying with the plug metaphor, you can manage what type of user can actually access certain information through each of these little ports. And you can kind of control, no one knows how your data is structured, because say you're storing passwords or something, you don't want any user anywhere to be able to go just like look at the code for your data and figure out whose password is what. And so you have these secure ways of accessing it, and you can manage control of that. Um, you know, you could have, a super massive, complicated tool for doing something that the user can access really simply, and you hide that all away from them. And yeah, there are drawbacks to it though. So first thing is, we've all experienced this, you're in a tunnel or something and you want to play your song on Spotify and you can't get the connection. And so, it requires an internet connection to work, which is maybe a drawback. These nested layers of complexity mean that there's really nobody out there who like fully understands how something like Instagram works. Even the engineers at Instagram, like they have their own little silo of things they're worried about. And so that's kind of a problem sometimes if you want to uh you know maintain it, or you want to change the structure. These systems get so big and so bloated that it's very hard to move things around. You have these things called like lines of legacy code, which is code that no one who is currently working at Instagram actually knows how it works, and it was written 10 years ago in a language that's not super common anymore or something like that. Facebook's famous for this. Facebook was originally written in this language called PHP, and it was totally hacked together, and the philosophy was very much move fast and break things, if you've heard that one before. And the system is so poorly designed that no one understands how it works, and it's miserable to change, and Facebook developers kind of tend to be unhappy with that, but they've been fixing it in recent years. But okay, part 3, web APIs for the SSPI. And so we're going to be using the get method of HTTP to get lots of data out of the SDG database or the UN database or whatever database we're trying to query. And data APIs usually return information in what's called JSON format, which is JavaScript object notation. And that sounds really scary, but it's really just a Python dictionary, if you've seen that before, or like it's just a set of key value pairs. So it'll look something like this: indicator, biodiversity, country, Argentina, year 2018, value 35.77 or something. It'll just have basic information stored in some kind of standard way, so that we can use some code to just figure out, okay, we want the indicator, we want the country, we want the year, and we want the value. We ask, this file for that information, and we store it in a table. And we're going to do all that in R. And so this is how it's going to look for the SSPI. We're going to do the appropriate request, and we're going to sort of store that appropriate request. And then we'll read the documentation and figure out what that is and save the request we're using so we can use it in the future. We're going to parse the request, which is what I was saying here. We're going to figure out what we want from it and store that information table and pull out exactly what we want. And then we're going to clean the data so that we only hang on to what we need for the SSPI. And then we're going to export the data as a CSV to Google Sheets. All right, that's it. So now we're going to sort of get into how we do this in R. All right, so now let's pop on over to R and see how, making this kind of request for the SSPI will actually look. Okay, so there are a lot of lines of code here, but I promise you it's not too complicated. And so we're going to use a couple libraries, and libraries in R are just these things that pull in some extra code that somebody's written that make your life easier. So it's going to pull in some functions that will allow us to manipulate the data in the way we want to. So we're going to use hitter, HTTR, or HTTR, which is using, HTTP requests, and it's sort of figuring out how to do those. And then we're going to use dplyr, which is a data manipulation package, JSONLite to parse the JSON files, and library.datatable, which is just a nice way of storing data sometimes. Okay, so the first thing we need to do is actually figure out what URL we want to call. And you can see it's a really long one. And the reason it's really long is, let's see, let's actually go to the UN data here. So UN, where is this? UN stats, API, SDG, API documentation is something you can Google, let's say. And we're going to try and figure out exactly how this works. And this is actually a really good site to sort of learn for the first pass at what APIs are. And so we are going to get data. And the way we're going to get data is indicators, right? We want to get data by SDG indicator. And then we don't want the list of indicators. This says it returns the list of SDG indicators available. And then we don't really want we want the data. So this is this API. And so we're going to click on this one and it's going to tell you exactly what it means. And when I was saying that APIs are a well-documented way of getting information, this is what I mean. Implements returns a list of observations filtered by the parameters defined in the call. And what the call is this long URL. And so this is the example. So this is JSON and this is JavaScript object notation, but it's really just a little dictionary. It says, what is the size? Well, it's 0. What is the total elements? Well, it's 0, blah, 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 blah. And so what we're going to do is we're going to say, what indicator do we want? Well, we want 12.4.1, which is the one we're going to be using for this example. This is the SDG indicator code. And then let's run the request and see what we get. Try it out. And it says, we're using curl-x get header, except this. And header argument here is just adding a header to your get request, and that's not particularly important, but basically this is what we're doing. And it says, okay, it returns size 25. There are 1,800 total elements, 74 total pages, and then, here are the individual observations. So let's see if we can get down here so we can actually see something. Yeah, description, Basel Convention, description, Montreal Protocol, Rotterdam Convention, Stockholm. So this is telling you the sort of dimensions in here. These are the different types of things they're considering in the data, and then you start getting data values down here. And so these data values are, this is for Africa, and I'm sure this is average, parties meeting their commitments and obligations, transmitting, blah, blah, blah. And so you can see there's a ton of information here. And so we're going to figure out exactly what we need later. But what we can do is actually add additional arguments to pare these down. And so it'll say here, area code, where do we want to consider? Well, we want to consider the 49 SSPI countries, and coincidentally it's M49, but that has no relation to the fact that there are 49 SSPI countries. And so what I've done is I've just pulled down the M49 codes for the SSPI. So there are different ways of identifying countries, and here we are with the M49 codes. So there's this COU, which is a standard UN notation, but they're actually using the M49 codes here, probably because they're easier to parse in the URL. And so what we can do is we can just copy these M49 codes, which are the codes for the SSPI countries, into here. And yeah, this is an integer array. And so now these are all provided as arguments. And so our curl URL before looked like this, it just says data, and you have this question mark, and then here are the query terms. And so it's indicator 12.4.1, right? And now when we try it out, you're going to see we get a whole bunch of new arguments. So it's area code equals this and area code equals this. And these are all of the values we've actually put in for the area codes. Perfect. So we've got a whole bunch of stuff in here. And when we try it out, now we have many fewer elements. We've gone from 1,800 to 423. And now these are just the ones we want for the SSPI. So this is the documentation for SDG. Now, all of the different sources are going to have slightly different documentation, but they're all going to look something like this. They're going to have this curl URL. Let's find the curl. Here it is. It's right down here. So they're going to have this curl URL. There might be a header, but that's not going to be particularly important. And then, it's going to have HTTPS, colon, and then there's going to be a question mark, right? And the question mark is saying, okay, now we're accepting arguments, which is for our query to the API. And so the arguments are, well, what indicator are we looking at? 12.4.1. And if we got rid of that, we would get a whole bunch more data, right? So if we're looking for this, we're going to query all of it, and it's going to be like way too much data to deal with. And so if we try it out, it's going to take a long time. And yeah, there are 500,000 lines that they've sent back, and they've only sent 25 of those, but there are 20,000 pages, and we definitely don't want to deal with all of that. And so providing the argument is just going to allow us to pare down and filter out some of the data so that we don't overwhelm the UN servers by sending too many requests, right? And we don't want to get the requests for all the data we need. We don't need it anyway. So yeah, now we just specify area codes, and we might not always do that, but for this database, it works really nicely. And yeah, so then what we can do is we can copy this request URL, and this request URL, if I put it here, you can see what we get back is exactly the JSON file we were looking for. And what we can do to page through it, you can see we have size, and we're on page 1. what we can do to page through it is we can say page equal to, and now we're on page number 2. And we've got new data down here. So you can see we had like Finland, France, Germany, Greece. And now what we can look at is area code page 3. And you can see we're going to the next page, Latvia, Lithuania, and you can see these are all the SSPI countries, and this is great. So what we're going to do is set up a script, which is just a file in R, that is basically just going to do this paging for us. And then it's going to look through here, and it's going to pull out exactly what we want and put it in a nice table. And that's all we're doing. So we want to be able to page through all, let's see, 17 pages here and do that really quickly. And we're going to look through this JSON, pull out the information we need, and put it in a table. And that's all we're doing with the API request. So this is sort of similar to our Instagram request earlier. It's just when we send this particular URL out, you can see it's an HTTPS request, and then it goes to this computer, and this folder is probably this computer here, and in this folder on that computer, it's looking for the things that satisfy this set of conditions, right? And then it finds it, and then it gets it and sends it back to us in this JSON notation, which is the curly braces with the, key and the value and commas separating all of it. All right, so that is all we need to start working on the script. So now we're gonna pop on over to R. Perfect, so we're in R now. We've got our libraries loaded, which I talked briefly about earlier, and then we have this URL, and this is exactly the one we were looking at before. And it starts off without a page argument. And then what I'm going to do is set, this is my URL. So this is just the assignment operation. You can think of it as equals. It's saying the URL, when I type this, what I really mean is this. And this is the name, the variable name for this. So it's like saying x equals 5, URL equals this string. And then what I'm going to do is I'm going to send the GET request to the link above. And the way I'm going to do that is I'm going to say GET, and this is coming from this header package here, and it's going to be GET of URL. And, this is just like what we were doing on the command line with curl-x GET. This is basically just doing that same thing in R. And then it's going to put the response into this res object, which I have for, maybe I'll call it response. And so first thing we do is write down our URL, and then we just say GET of that URL. And so if I run, let's see, I'll load these packages in, and all this is doing down here is saying I've loaded the packages, and it's telling you some stuff you might want to know. All right, URL has been saved, and now I'm going to send the response, or I'm going to send the GET request, and I'm going to record the response. And so now if I look at response, this is a special object in R, and down here. So what I'm doing here is I'm hitting Command Enter to run the line of code, and that's why things are happening. So I'm saying, okay, this is my response, and it tells you where did I get it from, and it tells you the date, which is, this is in London right now, or whatever, wherever the database is. It's 522, or 722 rather. Yeah. And then the status is 200. When you see status 200, you're happy because 200 means good. A status code of 400 means there was an error on the server side usually. And so you might have seen 404 error not found when you're like browsing and you type the URL wrong or something. That means that, it went looking, but there's no server that has that and it couldn't find it. And so it returns a 404 error. Your data wasn't available. They looked for the response and the response failed. Okay, now we have content type. It's telling you it's a JSON and it's got a size, which is 17.7 kilobytes, which is not too big. And that's nice. And so, yeah, if we look in there, now we need to parse the response. And so now we're using this sort of JSON light library, which is just saying from JSON, raw to character, and then, okay, let's look at this response object. So in R, there are different ways things get stored, and this is an object, the response thing is. And what that really means is it's a list. And it has this really ugly notation of how things are, but it says it's a list of 10 different types of elements. And the elements it contains are the URL, a status code, a list of headers. So this is a list inside of a list. And then it's got all sorts of other stuff, all headers, yada, yada, yada. But then eventually it's got something that has content. And so content is what we're looking for. Content is the actual JSON file. And so if we do this sort of $ notation in R, again, R is really ugly, and don't worry too much about what these things mean, but we're basically saying, look inside the response and get me the content of the response. There are other things in the response, but I want the content. And so let's do that. And you can see this is not human readable. And this is what's called hexadecimal notation, and it's an efficient way of encoding stuff. And then what I can do is I can say raw to character. So this is the sort of raw stuff, but if I go raw to character of response content, then here we go. We've got this nice string, and it's sort of decoded the information into the stuff you might want. And then all we're going to do is say, parse this file. So from JSON, which is from our JSON-Lite library, we're going to parse it by reading through this and extracting the information we want. And then we'll store that inside of parsed response, which is exactly what we're doing down here. And so just to recap, we've gotten our URL, we've gotten the response from it, and then we have parsed it into parsed res. And so what we can do is we can run this line, and then we can look at parsed response. And this now is a nice set of data values. And all this has done is taken all of the data that is stored in the JSON files and made each one into a little line that has, exactly the information you want. And so we can do this kind of view operation. So view in R of parsed response is going to open up a new window. And this is one of the reasons. Let's do parsed response data. Yeah, so this is the data we want to see. And you can see now we have, goal, indicator, target. So we've got indicator 12.4.1, and we've got Argentina, and we've got a time period 2015, and we've got a value, and the value is 100. So 100% of obligations are met under the Montreal Treaty. Perfect. And so now we just want to parse through and page through all of the data. And that's what this next block of code is doing. So you can see we've gotten one page. Let's go over to parse response data, but you can see that only contains 25 entries. And that is exactly what we saw in here. In here, you can see size is 25, and 25 is not all of the data. And how do we get the rest of it? Well, we have to page through. And so we're going to use this sort of page idea that we've talked about before, which is here. So we're on page 5, let's say, but we want to go from 1 to page 2 all the way down, and you can see the values are changing. And so we just want to set up a script that does that automatically for us. So we're going to pop back over to R, and we're going to go into our R file. And what are we going to do? Well, first we want to figure out how many pages we have, right? And we can see that because the parsed response, just to look back at the parsed response, it's got some information for us. And when we, what has happened? I've hit Shift Enter. Let's stop this real quick. Stop. Hit the stop button. Okay, perfect. So then what we can do is we can run stir, which is telling us to look at what the object is. And, if we just type parsed response, it has a way of displaying it, but we would just want to look at parsed response here. And when we do that, we can see that they've got certain things here. And let's see, can we find what we want? Yeah, total elements, total pages, 17. Page number 1. And so we want to extract parsed response $ total pages, because that's the argument here. And so we just want that line. And you can see if we do this, parsed res total pages, nice, is 17, which is exactly what we want. So we store that in n pages. Then we say Stockholm data, which is going to be our sort of object that we're storing the data frame in. We're going to make a data.frame of parsed res data. And what is this? Well, that is just the data frame we were looking at before. This is the page 1 data. And then what we're going to do is select columns 1 through 18, which is going to get rid of some of the ugly stuff on the end. So before we had, let's see, before we hadn't selected anything, and we have these like NA, get info URLs. We don't need this stuff here. and it actually was causing some problems for me. So I dropped the stuff. And so now we have just what we need. And we're going to store that as the data we have so far. So Stockholm data, which we're looking at the Stockholm Convention, which is why I'm calling it that, is the set of values we have so far. It's sort of the working database, and we're going to keep adding to this as we call new pages. And so what I'm saying is for I in 2 to n pages. So if you've never seen this before, this is called a for loop. And basically what it's going to do is going to run this block of code once with I equal to 2, and then it'll go down to I equal 3, and then it'll go down to I equal